Hi guys, how's it going? Today I'm going to go through level 1 of OpenZeppelin's Ethernaut series. The first level is fairly straightforward and it involves something called the fallback method. So the objectives of this level are to claim ownership of the contract and then reduce the balance of the contract to 0. Now, before attempting this level, you should know what the fallback method is. And basically, it's a special method in a smart contract which is invoked on a couple of conditions. One of the conditions, which is what I'll use today, is to simply leave out the method name when sending a transaction to the contract. And you can tell that a fallback method is a fallback method because it's missing the function modifier. So in this case, this receive method is the fallback method. And that'll be executed, as I said, if I send a transaction to the contract without explicitly stating a method name. So, without further ado, we'll go through this contract in a bit more detail to see what we can utilize in order to get through these objectives. First, there's this contribute method, and on a glance, it requires a value of less than 0.001 ether to be sent in, and if it is less than 0.001, then it will increment our contributions by that amount. And then if our contributions then exceeds the contributions of the owner, we can get ownership of the contract. And that's our first objective. So at a first glance, this might seem like the way to achieve it. But you'll recall that you're only allowed to send less than 0.001 ether. And looking at the constructor, the current owner has 1,000 ether. So if my math is not incorrect, we'll have to call the contribute method over 1,000,000 times just to get enough contribution value to transfer ownership to us. So that's probably not the ideal way. Thankfully, looking at the fallback method, you'll notice that there's another way to transfer ownership to us. And this is a lot easier. It only requires that the message value is greater than 0 and that we have a positive contribution. So, based on that, we can sort of devise a game plan. First, to get a positive contribution such that this will be satisfied. And then we can call the fallback method with a non-negative value, and that will satisfy these two, and then we'll get the ownership of the contract. So let's try that. We'll open up DevTools. We'll get the instance of the level first. Accept. Cool, so now we have the contract instance. We want to call, we'll do await since it's asynchronous. We'll do await contract.contribute, and we'll want to send a value which is less than 0.001 ether, or else it won't be called. So from player, which is us, and then we want a value which is in way, so we'll use this utility method which is defined in the contract to convert something less than 0.001 ether, so we'll just go ahead and do 0.0001. We'll call that, confirm it. Alright, that's done. So that should have given us a tiny bit of ether so that we have a positive contribution value. We can check it by going await contract.getContribution. We'll define a value, so my contribution, so that we can see it. Oops. There we go, and then we'll do, since this is returned as a bn, a big number, we'll have to do something like .toString. So this is the amount of away we have, which is 0.0001 ether. So we have a positive contribution value. Now we just need to call the fallback method. And to do that, like I said earlier, we need to call the contract with no method at all, just send a transaction from player, and any value at all, because it only requires that it's greater than 0. So we can do anything. We could do 0.0001 if we like, and that should do it. Alright, so if that went all as planned, we should have ownership of the contract now. We can check that by calling contract.owner. Contract.owner. And this is precisely my public address. So 64A96B, 64A96B. Cool. Now that we have ownership of the contract, we can go on to part 2, which is to reduce its balance to 0. And to do that, we can use this cool method here called withdraw. What this does is it transfers the balance of the contract, which is what this line does here. Address this refers to the contract itself, and it transfers that to the owner. So we'll go ahead and call contract.withdraw. And now the contract should have a balance of 0. We can check by going await get balance contract.address 0. Cool. So we have ownership of the contract, and the contract now has a balance of 0. And if we submit the instance, we should have passed. Awesome. Cool. Thanks for watching this video. Hopefully it helped you in some way. Hopefully you have an understanding of fallback methods now and not what to do with them. Let me know if you found this video helpful. Let me know if you want me to release more videos on Ethernaut, and I'll be able to cover the rest of the levels. Thank you.